So this lesson is going to be on solving systems using elimination. This will be lesson 4. So let's review really quick what we've done. We've done solving systems of equations using graphing. We've done solving systems of equations using substitution. And then lesson 3 was on some word problems. So lesson 4, solving systems using elimination. It's the last of the 3 methods to solve. So basically with this one, it's going to be for when you don't have a variable alone. So if you remember with substitution, we were constantly looking for like a y equals something. And then we would circle whatever that is, and we would put it into the other equation for whatever the y was using a substitution method. This one is going to be when one variable is not alone. So it's going to be something like this, ax plus by equals c, where obviously a, b, and c are probably numbers. Okay, so are they in the same form? They're usually lined right up. Is there a pair of opposite coefficients? So look for those, like one has a -2 and one has a +2, or one has an x and one has a -x, something like that. If yes, then you want to just add the equations so that one of them is eliminated. If not, then you're going to multiply one or both equations to create a pair of opposite coefficients. And then you're going to substitute. Please make sure in the end that you still state the solution as a coordinate pair, so it should be x and y, and then check your answers. Okay? So if you're looking at these ones right here, ignore all these. I don't know why those are there. If you're looking at this first right here, if you look at this 7x and this -7x, that's that opposite coefficient thing. So with that one right there, we would use the elimination method. Okay, so because of the opposites, we would use this. We're going to go ahead and just add those 2 equations together and then see what happens. So this one right here would be in the elimination section. This one up here, so I'm looking at the one at the top now. Again, if you look at this, we have a 5b and a -5b. So again, we're going to add those 2 equations together. A -5b and a +5b will cancel and will leave us just equations with a's. Now this one right here below that one has a y equals. So this one, we're actually going to use the substitution method because we already have what y is solved for, and that will go in for that y right there using parentheses. So substitution. This box right here, again, this is going to be an elimination, but this one's going to need a little bit of work because there's a +1p and a +1p. Well, if I add those together, the p's will not end up canceling. So I'm going to have to multiply this whole second equation here I would do by a -1. So we'll use the distributive property to multiply that -1 through so that then when we add, they do cancel. It's still the elimination method, but with a little bit of work. And then same thing with this last one here. Nope, this one's going to be a substitution, and that's because that d is solved. So d equals this. That will go in for that right there using parentheses, and then you would solve. So you can look through those and see if you agree with those, but those should be which ones I would use substitution and which ones I would use elimination. Okay, so how we start with this. So solve the system algebraically using elimination. They will never tell you what to use. You have to pick this. You have to choose. So if you look here, the key giveaway is going to be right here because you have a +5y and a -5y. So what we're going to do is we're going to add those 2 equations together. A 2x plus a 6x, that gives me an 8x. A +5y and a -5y cancel. That would be 0, and that will be equal to 17 minus 9, which is 8. Okay, then you draw your railroad track and you solve. So you divide by 8, and you get x is equal to 1. Now we are not done yet because we need to take that 1, plug it back up into an equation, and solve for y. I'm going to use this top equation right here. So instead of writing 2x, I'm going to have 2 times 1, because remember, x is equal to 1, plus 5y equals 17. 2 times 1 is 2, plus 5y equals 17. Draw my railroad track, start to combine those like terms together. They are on opposite sides, so I'm going to subtract a 2 from here and subtract a 2 from there. I will get 5y is equal to 15. Divide by 5, divide by 5, y is equal to 3. So my final answer is x equals 1, y equals 3, or the coordinate pair 1, 3. Example number 2, solve the system algebraically using elimination. Again, they won't tell you this, but this is another obvious one. If you look here, you have a positive 2y and a negative 2y. We're going to add those together to get them to cancel. So add those two. 5x plus 8x is equal to 13x. The 2's will end up canceling. That will be equal to 10 plus 16 is 26. Divide by 13, divide by 13, x is equal to 2. Now we're not done because we need what our y is equal to. So I'm going to go back up again to that top equation. 5 instead of x, I'm going to write 2 plus 2y is equal to 10. 5 times 2 is 10 plus 2y is equal to 10. Draw my railroad tracks, subtract 10, 2y equals 0. Divide by 2, divide by 2, y equals 0. So my answer is x equals 2, y equals 0, or the coordinate pair 2, 10. Now, to check your solution, you should also be able to plug it into the bottom one, and you should get that to work out as well. So just for fun, let's go ahead. For the check, we could write 8 times 2 minus 2 times 10, and we want to know, does that equal 16, which I don't think it does. Did I make a mistake? I don't think so. Oh, that's a 0. That's not a 10. That's a 0. See, good thing I checked. So that's a 0 right there. 8 times 2 minus 2 times 0. We want to know, does that equal 16? And it does, because that would be 16 minus 0, which does equal 16. Check. So there we go. I just saved myself an error. Okay, number 3. Again, they're not going to tell you using elimination, but you would look at it and you would see that it's all lined up. There's not one that's solved for the other. Now, this one has a slight issue. If I go ahead and add these right now like I did with the other ones, I would get 3x plus 2x is 5x, but a negative y and a negative y is a negative 2y equals 5. Nothing canceled out, so that was not helpful. So instead of doing that, we're going to go up and I'm going to multiply one of these equations by a negative 1, because if you notice, this one right here has a negative y and this one has a negative y. So if it was just opposite, then it would be, it would cancel. So I'm going to distribute through by that negative 1. So that will give me the new equation, negative 3x plus y equals negative 4. So all I did was change all the signs. The positive 3x became a negative 3x. The negative y became a positive y, and the positive 4 became a negative 4. Now when I line things up exactly as it was and add those two equations, a negative 3x and a positive 2x is a negative 1x. These will cancel, and that will be equal to a negative 3. Negative 4 plus 1 is negative 3. Now I'm going to divide by negative 1 on both sides, and I will get x equals 3. Again, not done. We're going to go plug it in. You can plug it into any of those 3 equations there. I might use that bottom one this time. Again, it doesn't matter. 2 times not x, x is equal to 3, minus y equals 1. That gives me 6 minus y equals 1, minus 6, negative y, that's that railroad track thing, is equal to negative 5. Divide by negative 1, divide by negative 1, y equals 5. So my point would be 3, 5. Okay, looking at this right here, again, like the last one, I've got a positive 5x and a positive 5x. Right now, they combine to be a 10x. I don't need them to be a 10x. So what I'm going to do is I'm going to change all my signs or multiply them all through by a negative. Go ahead and add. Those will cancel. I'll get 3y because I have a 1y plus a 2y is a 3y, and a negative 15 plus 20 is equal to 5. Divide by 3, divide by 3, y equals 5/3. Okay, we're not done. We're going to go up and plug that in. So I'm going to plug in this bottom one right here. I have 5x plus 2, not y, but 5/3 equals 20. 5x plus, that would be 10/3 equals 20, minus 10/3 from both sides. I'm going to have 5x equals, let's see, 20 minus 10/3. No, we're going to get a decimal on this one too. In order to subtract those, I'm going to clean up this side over here. So I'm going to put a 3 right here, which means I need to multiply that by 3 for a common denominator, which is going to give me 60 minus 10/3. That's still equal to 5x. 60 minus 10 is equal to 50 divided by 3. So the last thing I'm going to do is divide both sides by 5. So I'm going to have that x is equal to 50 divided by 3, and then divide that by 5. That's also the same thing as multiplied by a fifth. We could have multiplied both sides by 5. To simplify that, this would go to a 10. This would be gone. So we'd have 10/3. That's kind of a messy one. So answer 10/3, comma 5/3. Okay, this is the last one that's kind of tricky because now if you notice, we don't have any that will cancel out even if we change all of the signs. So what I would do is pick the one if there is one that's already opposite. So like this one has a 5b and this one has a negative 2b. So what I'm going to do is I'm going to multiply this one up here by 2 and I'm going to multiply this one here by 5. So I'm going to distribute that number right through. That will give me 4a plus 10b equals 8. And then 15a minus 10b is equal to 30. Now I have a positive 10b and a minus 10b, so those will cancel when I add. So I'll get 19a is equal to 38. Divide by 19, divide by 19, a equals 2. We're not done. You have 4 different equations to choose from. I'll choose that top one right there. I just usually look for the one for the most positives. So 2 times not a, but 2 times 2 plus 5b is equal to 4. 4 plus 5b equals 4, minus 4, minus 4, 5b equals 0. Divide by 5, divide by 5, b equals 0. This one I would not write as a coordinate pair, just because it's not an x and a y, it's an a and a b. Okay, we're getting down there. I'm going to do one more. This will be the last one that we do together. So we'll stick with number 6. Okay, so again, none of them will cancel. So, and none of them are opposite. So I guess it doesn't matter what you choose. I'm going to just choose this top one here. So I'm going to take this 3 and multiply this through by negative 3 and this one through by 2. What I did there was I chose the 3 from down here and I chose the 2 from down there and I made one negative. So now when I distribute that negative 3 through, I will get negative 6x plus 9y equals 0. And on the bottom, I'm going to distribute the 2 through, which will give me 6x minus 4y equals 10. Add those together, those will cancel. You get 5y, 9y minus 4y is a 5y, equals 10, divided by 5, divided by 5, y equals 2. We're not done. We're going to plug it back in. Again, it doesn't matter. 2x, I'm going to use that top one, minus 3 instead of y times 2 equals 0. 2x minus 6 equals 0. Add 6, 2x equals 6, divide by 2, x equals 3. Right, my answer is a coordinate pair, 3, 2. You can also graph these as relations and see if they, if the answers are correct. Okay, you can also check by plugging them into both of them and making sure that they work. Okay, I think that will be good, and we'll work on the rest in some small groups.